right, good morning, CES. How's everyone doing? All right, if you've ever been to a talk show, they have this person who comes up first. They're not very important, but their whole job is to get the group excited and energized for how amazing the panel is. That's my job. First, Alex Pana, Senior Partner at McKinsey, responsible for our client service globally. Thank you so much for joining us today. It's a shame we actually couldn't fill up the room. Maybe next time. But most important, we have an incredible panel. We got our friends from Qualcomm, Google, Boston Dynamics, and General Motors. And if you reach under your seats, and if there are a set of car keys, that is a new Silverado that General Motors gave to you tonight. That's a different talk show, friends. Sorry. Most important, I'd like to introduce Ani Kelkar, who's going to lead our panel today. Thank you, and have a great time.
Thanks, Alex. It's very exciting to be here at CES. Well, we live in a world where we have significant challenges from a labor productivity and availability perspective. Automation is back on the CEO agenda. It's no longer being treated as a capital purchase within an operations context, but something that becomes a transformational capability for organizations. And we see this in the numbers. In the US, the Bureau of Labor Statistics estimates that we will be short of 1.9 million manufacturing jobs by 2033. We also have only automated at scale 6% of our manufacturing facilities. And in 2025, China installed 10 times as many robots in their production sites as the US. So the imperative is there, the excitement is there, and we're seeing significant number of enterprises move in that direction. The amount of mentions about robotics and automations in public filings from industrial companies has more than doubled in the last 18 months. We're seeing significant companies move from demos to pilots to early transformation programs. But we've been here before. Robotics and automation is not a novelty. It's been around for several years. And so as we look forward, it's important to take some lessons from the past. Why didn't we have automation at scale so far? When we surveyed executives, and we asked around 200 executives globally, 3 things stood out. One, the business case barrier to automate was quite substantial. And this is not just about the robot. This is about all of the other environmental and infrastructure spending that goes into making a robot useful. Secondly, while technologists are innovating and pushing the frontier of what's possible, organizations lack catchers and internal capabilities to make value from those innovations. And finally, there is an underappreciation of technology readiness beyond the robot in terms of infrastructure, whether it be networking or interoperability standards. But times are changing, and that's why I'm excited to bring on stage a stellar panel to talk about what's the future of robotics and automation and how we're going to transform industries through this disruptive technology. First up is Michael Taylor. She is the head of robotics strategy at General Motors, responsible for deploying autonomy and robotics inside one of the largest manufacturing and mobility organizations. Next up is Robert Plater. He is the CEO of Boston Dynamics, one of the few companies deploying highly capable robots into real industrial environments today. We now have Carolina Parada from Google DeepMind. She leads robotics research, working on the frontier of generalizable AI and how intelligence transforms from simulation to the physical world. And finally, we have Nakul Duggal, who is the Executive Vice President and General Manager at Qualcomm, where he leads platforms that bring AI and compute into real-world systems, from robots to vehicles to edge devices. I'm excited to get this panel underway. Thank you all. I think one of the first conversation pieces that has been top of mind for everyone has been, what's changed in robotics and AI? What's different today from 5 years ago? And maybe, Carolina, I'll start with you. As someone who's been researching this space for a while now, robotics has always felt perpetually ready. So what are you excited about? What's different now?
Thank you. Thanks for having me. Can you guys hear me OK? All right, cool. AI in robotics has changed dramatically over the last 4 years or 5 years even. starting, say, for example, 5 years ago, robots really didn't understand their environment, like with all the richness in it. And you have to essentially code every single step that the robot could do. Since then, obviously, the field has introduced foundation models into robotics, which enables robots now to understand natural language and visual input and combine both of them in order to reason and plan and even take action. There's also been significant work around introducing, of course, transformers and VLAs and LBMs, right? Which now bring into robotics the idea that if you can provide significant data that represents actions, then now these robots can learn and get better over time. That's a huge shift as well. And I think many of us have been actually quite surprised how much you can do with this. Like even we have examples today all the time about robots doing laundry and robots tying shoelaces. And these are things that before were considered impossible, or people will be like, I'll retire if the robot can do that, right? It was quite hard. And so it's really shifted quite dramatically. There's also been a significant effort around and maturity around reinforcement learning and sim to real that has really made robots go from just very fixed type of tasks to just mimicking an entire sequence that can look quite advanced from a human. So significant progress, and I'm super excited about where we're going now. And 2026 is going to be awesome for robotics.
Amazing. Well, what a great note to start off with. And Nakul, you've been building compute platforms for vehicles to make them autonomous and have recently announced your platform on robotics. Why now?
I think Carolina said a lot of things that echo very well. I think first of all, it comes to scale. I think over the last 10 years, if you think about the amount of energy that the industry has spent on really physical AI, self-driving cars, automated driving, the ability to be able to solve real-world problems that actually make an impact to everyday products. And I think the last 10 years, the industry has realized there is a tremendous amount of scale that you have to be able to bring together. The hardware, the sensors, the ability for you to be able to, as Carolina said, perceive your environment and then be able to act on it. Robotics to me is taking that to the next inflection point where there isn't really on the XY axis any limit to what you're trying to go automate. So it comes down to all of the work that's happened in the robotic space over the last 2 decades. Locomotion is a well understood problem. How do you sense your environment is a well understood problem. But in the context of creating the equivalent of a foundation model for physical AI, what will that bring as potential? So for us, that is why this space is so exciting, and I agree it's going to move very fast.
Amazing. And Robert, we've all watched YouTube videos of Boston Dynamics. Is 2026 when we shift from cool robots to useful robots?
I think it's already begun. I think for the 30 years I've been doing robotics, it's been a niche, and it's been dominated by YouTube videos and prototypes. And I think the interesting evolution that is happening now is scaled adoption is actually starting to happen, right? We have over 2,000 spots with customers in factory settings doing useful work today. We have partner companies, OEMs, large-scale industry providers, component providers, who want to get into the robotics business, whether it's building batteries or actuators or sensors. And ultimately, that's what's going to be required to sort of scale this industry, is that industrial might behind it. Our largest owner, Hyundai, is building an entire ecosystem around fabricating the components and parts for robots so that we can approach scaled manufacturing.
And it was exciting to see the 60-minute segment of Atlas doing activities at the Hyundai factory. Mikhail, coming to you, does this shift feel real inside a large industrial company, or are we still in sort of the early doors?
I think it depends on the technology. I think that there is currently certainly an inflection point for industries like automotive, logistics, that require incredibly high reliability and availability that a lot of technologies that have been around 10 years are ready for now. I think that a lot of the more modern technologies like the AI that's coming out now and embodied in robots has a little bit of a ways to go in development before it's ready for those industries. But these industries adopting these other technologies now will be primed to adopt these newer ones the moment they're ready.
And what do you think is needed for these newer technologies to scale? How would you envision the path from pilots to actual commercial deployment across your network?
It's a lot of reliability and predictability, right? Which is not a thing that a lot of the modern AI technologies excel at. And it comes down to the hardware too, right? Cheap hardware is good and useful and has good ROI, but things are in very kind of high demand environments and need to have good lifetimes, and that's very different from kind of consumer hardware. So both the hardware and the software need to be ready to perform in the environments that are demanding a lot of them.
And Carolina, how do you sort of parse with all of the frontier foundation models are imbuing new capabilities in robots, from folding laundry, as you described, to sort of the industrial context of requiring reliability and throughput. Where are we today? Can you help us calibrate in terms of capability versus industrial readiness?
Right. I think that's a great question. I think it is not a binary answer that AI is going to be ready for full commercial deployment all at once. I think what will really happen is you'll start leveraging AI in many different contexts. Perhaps you have your entire industrial automation fleet already going, and now you're leveraging AI to maybe get a better understanding of the site, a better reading of the instruments, and that way will continue to evolve. And then I also think that part of what AI creates is an opportunity to expand the set of applications. So we're not talking about just taking the existing robots in the existing places and just making them 10% more efficient. We're talking about opening up a completely new area where before you didn't even think about deploying a robot because there was so much variability, so much flow of materials and changes that you couldn't handle it before. So I think there's going to be a combination of integrating some AI technology into existing deployments to augment it. And then there's going to be opportunities to explore new applications and new verticals and new areas to start expanding it. But it will take some time because obviously, as we all know, it's very different to use AI as a chatbot than it is to use it in a physical application on a robot. So there's going to be different standards. There's safety constraints, right? There's a lot that needs to be done.
Can I add something? Because I think today there's functionality that exists today. The robot can recognize a gauge or measure the temperature of a motor and detect whether or not it's failing. And AI provides this opportunity for the same platform and almost all the same software to now start adding new functionality. Maybe that's a security patrol, recognizing that a door is open or closed, recognizing if there's a person there who shouldn't be there. And so I think we've definitely, the challenge with robotics is finding that first application that really pays for itself, because by the way, the first one has to pay for itself, right? But then the AI is going to add layers on. And so, then that will add gradually more complexity, more capability.
And Robert, maybe staying with you, what doesn't scale as fast as people think? Like you've deployed robots in the real world. What is hard to take from the lab and make happen in the real world?
Yeah, people's attitudes. It takes 2 to 3 years for our customers to get used to having robots in their facility to where they're ready to start expanding. And I think nobody talks about that yet. So there's this almost a cultural piece. I'm going to trust this piece of technology. It's doing a job I care about. We have to get better. But that adoption cycle we're seeing 2 to 3 years. And nobody who is predicting exponential growth thinks about that delay.
And Nakul, you've now sort of seen the autonomous driving trend from early pilots, a lot of excitement, then some sort of measured calibration to now what seems to be reality. Any reflections on how you see the robotics journey? Is it mirroring what happened with autonomy?
I think to build on what Robert said, I think it has to be assumed that this is going to be a continuously learning platform. You can't expect that it is going to get to its fullest potential on day one. But the idea that a human actually has to think about this platform as not a machine, but something that will, through AI, keep evolving, keep perceiving, keep getting updated, that I think is probably just net new. And I think of this more as, I think the big difference between autonomous driving and robotics is that autonomous driving is a transportation problem. there is no other real use case for it apart from transporting you from A to B. But with robotics, it is actually much more rich in terms of the opportunities because there is a greenfield aspect to robotics where today nobody thinks about automating an environment that requires surveillance, automating an environment where you want better situational awareness because the technology didn't exist. And then, of course, there are brownfield applications, warehouses, manufacturing, et cetera, where there is an adoption curve and all of the inflection points that come in. So I feel like you have to look at it through the lens of the opportunity, and then the technology adoption cycles can actually be quite different because the problem statement you're trying to solve is not quite the same depending upon where you are assessing it from.
And where do you think the greenfield opportunities will come from?
I feel like there is a certain societal aspect to it because there's the labor force replacement aspect. But from our point of view, I think two things are happening: an aging workforce and humans not wanting to perform functions that can be automated. As you start to apply that over the next, I think the next 5 years is going to be about robotics becoming exponentially better than it is today. The next decade is going to be about what are jobs that should not be performed by humans, that should just be net automated jobs. And I think there are several. I think there are several blue-collar jobs. There are several jobs that just require physical presence of a human that doesn't necessarily require the human to be present. That requires the human to be alerted because the robot is now bringing a human into the loop. Right? And I think you can just imagine so many environments where the deployment environment may need to be designed for robotic automation to be present, whether it's hospitality, it's healthcare, it's in the service industry, it's in the defense space. I think it's massive.
And Mikhail, Automotive has been a really large user of robotics and automation. It's been the primary market. How are you and GM thinking about this opportunity? What tasks, what else is left that hasn't been automated yet?
Yeah, a lot of the kind of traditional robots that you see in any automotive assembly line are primarily on the kind of body and paint side of things, right? And what throughout the automotive industry remains still very manual is assembly, final assembly of fitting the instrument panel, the seat belts, the windows, things like that. And so that's what really requires a lot of the advanced technologies being developed today, right? That dexterous manipulation and the intelligence to figure out that, the handle on this car that looks slightly different from the handle on the other model that's right behind it is the same thing, put it on the same way. A lot of that stuff is going to come out of these advanced technologies.
Amazing. And are these skills transferable, Carolina? Is assembling on automotive line similar to perhaps a butler robot doing laundry at home and putting away your dishes?
Yeah, I mean, actually, each skill is essentially just like we think of a skill as a verb or a motion. And I think as long as you're not memorizing, basically, that is the key thing here, that when you're trying to solve this from a more foundational perspective, then you're actually just trying to understand what is the motion that you need to do. And then you're also getting the feedback, the live feedback about what's happening. So if you're able to understand what it should look like, and you're able to get that feedback back into the system, then that's what allows you to adapt and to change. And so, yeah, we actually don't really think of learning just specific skills per domain. I think, obviously, a good thing to do is to have very clear benchmarks, very clear benchmarks for different domains. Maybe you have logistic benchmarks, manufacturing benchmark, and within that, there's also a lot of different areas. But fundamentally, you don't split a model to just work on one area versus the other, because a lot of them actually learn from each other. And actually, that diversity is what makes the model a lot more robust. If you start just learning, you could also spend the same amount of budget of data on just specializing, and you will end up with a model that is actually a lot more brittle. And so it's a worse use of your data budget. So certainly I think the better thing to do is to actually go broad and tackle as many different motions and verbs as you can. And actually in automotive, some of the tasks that she described, I've seen them and they look incredibly difficult. We're talking about fitting wire harnesses into little parts that look extremely hard. So there's a lot of diversity there already that I would expect would be really useful.
I think the more time you spend on robotics, you appreciate more how skillful humans actually are. And that's a sort of a little bit of an oxymoron. And Carolina, what are those bottlenecks today, right, from on the learning side of things? Is it access to data? Is it compute platforms? Is it, you talked about feedback? Is it the sensors?
Well, actually, one of the things is you're talking about how much to appreciate the human body. Like, the human hand is absolutely marvelous. It's like, I think even today with the more advanced robots, it's still hard to do the tasks that that you actually see in automotive, for example. So I think there's still some work that needs to happen around hardware development and sensing capabilities to get to the level where you can do what a human can. But there's a lot that can be done before we get to that level of dexterity, for example. What was your question again?
What bottlenecks do you think there are for learning? Is it data?
Oh, bottlenecks.
Yeah.
Right. Certainly, I mean, I think, first of all, there isn't like a full final recipe yet. I think there is a lot that we can still be doing to bring another level of generalization and intelligence into robotics. I think there's still breakthroughs to be had for sure. But having said that, given the current paradigm that we're using, certainly data is important, and diversity of data, not just the same kind of data. And then certainly you need to be able to physically do the task and have the right signals back. So if there's tasks that, for example, require pretty detailed tactile sensing and your robot doesn't have that, you're just going to be out of luck no matter how much data you get. And then reliability of the hardware, right? In order to collect that data, in order to do those tasks, you need hardware that is reliable, that can actually operate for many hours on end. So those are just a few examples. But I'm very hopeful that, you know, we've seen dramatic progress on the hardware side, dramatic progress on the modeling side. And yeah, I think I'm very excited about the pace at which things are moving, and I can imagine that both of them will have important breakthroughs in 2026 and beyond that will get us there.
Amazing. And Michael, when robots are introduced into real workplaces, how do workers respond? How do you design the integration of robots with work that humans are so skillfully already doing?
Yeah, and this touches a bit on what Rob was saying earlier about that kind of sort of adoption period. And this is what I actually find fascinating about robotics, the sort of user experience component of it, to prepare workforces for it, to engage them in the design process if you can, give them some ownership of it, and make the robots work for them. We did this at Amazon, where I led the AMR development program to a lot of success. There was obviously a lot of skepticism when the Proteus robot was announced, but it ended up being pretty well adopted early on. And we're aiming for exactly the same thing with GM. They know robots. They've had robots in those plants for decades now, right? This is just some new technology, new generations, and it's going to screw up initially, and we need to work through that and help them learn to trust it and be willing to start offloading work onto it as it matures. But that is a deliberate process. It's not an accidental process, and it has to be part of the product design and the deployment plan to do it right. And I think that's where a lot of companies struggle, is not accounting for that. You know, the first couple of years is the hardest problem to solve from this standpoint, right? It's people don't quite want to give up the work, you know, managers don't trust it. You still have a lot of people in the mix walking past, walking into a work cell, stepping in front of a mobile robot. That gets easier as the robots are allowed to do more of the work. So those first few years are a critical period to get it right. And it's not engineering, it's thinking about the human.
We like to say you can't go from zero to humanoid. So what Michael's saying is that there's a cultural evolution that your company has to adapt to hosting a fleet of robots and how people are going to interact with it. And frankly, you can do it today, and it can be an AMR, it can be other, but it needs to be a mobile robot, I think, right? A mobile robot that's moving amongst your workforce, doing some job that will let your organization begin to adapt, so that when humanoids are really ready, then your organization is ready.
And you brought up when humanoids are ready. When will humanoids be ready?
We're planning on, we're starting our testing with Hyundai starting this year, and more seriously in 2027, and actually beginning to deploy in factories in 2028. So we think it's three years before you're really seeing them in factories. And I know that's not something that some of the other leaders in the humanoid space are saying, but for all the reasons we're describing here, we think it's a little bit slower is going to result in a better outcome.
Got it. And there are regions of the world, China in particular, that are seeing a lot more activity on humanoids. It's a national priority. We had the Humanoid Olympics. Nakul, from your perspective, do you think this is evolving into one global ecosystem, or are there sort of regional ecosystems that are evolving from the silicon up?
I think there are certainly regional ecosystems because I think the applications are very broad. There is an opportunity in my mind for the supply chain to be much broader. I think for this technology to scale, cost is going to become important, and I think there is an aspect of the rate at which robotics gets to scale will be directly proportional to the number of end units you get deployed. So, as I talk to a variety of different customers, what I hear is you can automate, but inside a factory environment, for example, there are only so many physical robots that you need. So what you're trying to do is to improve productivity or bring in automation, but the number of end units that you will deploy are fixed. Now, going back to my earlier point about Greenfield, if you want to be able to scale this to a reliable supply chain, there is a need to be able to have a hardware supply chain that is much more global. We've been working with companies all over, from Japan to Germany, and I think there is a new supply chain for robotics that I think is emerging. There is a software and a data supply chain as well. That is net new, which I think, as Carolina and others mentioned, is actually moving very quickly. So the intersection of all of that is something that we spend a lot of time on. And I think that is going to be quite necessary over the next 5 years, such that things look a bit different than they look today.
And is that changing the skill set needed to be a roboticist in 2026 relative to maybe when you started, Robert? Is it much more ML, AI, data sort of focused than maybe mechanical engineering?
Well, certainly the mechanical engineering skills and electrical engineering skills haven't changed, but the AI skills are new, and sort of the method for programming the robots has largely been transformed in the last few years. And there's a huge talent war going on right now, folks paying incredible salaries to really skilled AI machine learning talent. And so hopefully that'll pass. Hopefully there'll be a lot of graduates who enter, and we'll see supply and demand kind of work its magic, but that's going to take a few years.
And then, Michael, as an organization, are you thinking about what skills do you need to have internally to be able to bring these robots, drive that change in culture, drive that adoption?
Yeah, absolutely. On the development side, on the integration side, on the kind of operations management side, right? The teams that actually are going to take on these robotic systems and operate them. So there's a kind of skills conversation across the board there, and I think companies that will do well at this will invest in that upskilling at every level of their employee organization to give them the ability to do the jobs that are going to come. If you have to compete for all that talent externally, to Rob's point, that's going to be a war no matter what. So the internal investment is going to be incredibly important.
And
if I can add something,
yeah.
I think actually part of what we want to is, as you expand the set of applications that these robots are helping humans with, right, as to augment their productivity, you really want to make sure that the robots are now able to be adaptable and instructed and taught by everyday humans. You don't need to be an expert. You should not be needing to be an expert in order to actually leverage these robots. So certainly that is an area I think where we need to do a lot more work in order to get the robots to just understand natural language, multimodal input, contextual information, connect to maybe the systems that are also in the factory. So I think part of the work is going to be not just get everyone in every deployment site to be an AI expert. It's actually about how do you make the robot and the models capable enough that anyone can actually interact with these robots in a way that it feels natural.
So you don't need to have a maths PhD to use Excel. Similarly, you don't need to have an AI PhD to work or interact with a robot. Maybe on that question, as you require at some point for robots to be trained or engage and collaborate with humans, a key question is going to be in terms of trust and for the humans to understand the capabilities of the robots. I think particularly in consumer robotics context. And when you move away from the deterministic program robots to learned robots, how are you thinking about the parameters for trust and how you build that?
Yeah, I mean, I think that's, again, another area that needs a lot of effort. Obviously, there needs to be significant levels, like multiple layers of safety that bring that trust. And it needs to go beyond, you just put the robot in a corner and cordon it off, right? Because now you're going to be in human-centric spaces. So we constantly think about all the different levels of safety that we need to be introducing, and that goes with, you need to connect with existing low-level controllers that ensure that there is like no failures and no collisions and limited forces and all of that. But you also need to start bringing in layers around semantic understanding of physical safety. If a robot now can do anything in your house, there's all kinds of common sense things that your kid at 5 years old knows should not be doing that are not going to be obvious to a robot unless you actually make sure that that is part of the training that it has. So semantic physical safety, and then also just proactive safety, content safety. There's multiple layers that we need to be thinking about. In terms of building trust, I think that, it's part of, it will be done over time when people see a consistent behavior, when people can see that safety in place. But obviously, I think I lean more on my colleagues here on the left who have experienced this. Even in the industrial setting, it sounds like it is hard, so it will take some years, regardless.
It's part of the reason why we want to start an industry is I think it's probably an easier entry point for safety, because you can build a safety culture in a factory that'll be a little bit more tolerant than in the home. But ultimately, the robots have to communicate in a way that indicate that they understand there's a person in the vicinity. They're going to modify their behavior in response to that. A lot of that's going to be driven by the AI, recognizing that I've got, a child, a pet, or a person here that I'm interacting with, and behave appropriately.
And to build on that, I think that letting people build mental models that allow them to behave safely around the robots is part of the safety story here, especially as they go into homes, right? I was talking with a staff member at my hotel yesterday who was talking about the Zoox vehicles, and one stopped kind of in an intersection with a crosswalk and just wasn't budging, and nobody knew, can I go around it? If I walk in front of it, what if it starts up? And so there was this like really unsure navigation of a whole bunch of people that were blocked by this because they didn't know what was safe. And that obviously can lead to people behaving in a way that creates an unsafe scenario. It can also really damage trust in people's trust in this technology, and it's going to hurt all of us from an adoption standpoint down the line. So the more that we can educate people not to be AI experts, but to give them a mental model of how these things think and behave is going to be critical.
And I think there's a really interesting issue here about, which is why humanoids. Everybody asks me why humanoids. And I think one of the neat answers is, we have a lifetime of interpreting physical behavior in other people. And if we can leverage that in a robot, so that the robot through gestures is communicating something in a nonverbal way, it's going to make this interaction just work way better. And I think that's a super exciting reason why to have highly articulated robots that are walking and moving with limbs and things like that. It'll make it just a whole lot more interesting to interact with.
I'd like to add a couple of thoughts on this topic. I think one thing that is fundamentally different between what we have seen with other automation, cars, etc., is you're replacing a function that is very well defined. And so if you are in the vehicle, you have a certain expectation. If you have a robotaxi, you have a certain expectation as to that its behavior needs to mimic what a real vehicle does. With a robot, there is an expectation as to the robot's awareness of the surroundings that it is in, especially when a human is present. And I think there is a big difference between a consumer robot that is a vacuum cleaner versus a factory robot that is operating as a worker in a plant. And I think that there is a tremendous amount of work that is still to be done in AI in terms of making a robot aware of its physical surroundings and how AI models evolve. Because today's AI models are still very much an LLM model that is expanded to videos, and now you're adding video language. But a physical environment now being something that you're codifying into what is a physical AI model. Within those confines, safety has to be built in. Because if the primary purpose of a robotic model is to coexist with humans, the model itself has to understand that so I think there is more work That is yet to come, but I mean, clearly the problem statement is understood.
And Nakul, is the bottleneck there just the model capability, or are there hardware limitations? Can you do all of that inference on the edge with what's available today?
Well, I think the models, I mean, the problem statement does have to exist in that it has to be solved at the edge. You can't go to the cloud to go solve these things. But you do have to be able to design models that perceive that safety is a built-in requirement. And therefore, when you are, for example, designing a reasoning model that is evaluating the environment around you, the presence of a human or an object or a physical structure that needs to be preserved as you take action has to be built into the way that the model is designed. Today's models are designed more for, let me reason to be able to take, to say perform a certain task. And then the action doesn't necessarily take that into account. That work yet has to be done. And that will create the next set of physical AI models that will certainly build safety as a trusted factor.
And what's the path to sort of scaling? I know you also, Carolina, mentioned new applications that will come in. There are a range of robots doing kung fu videos. I'm sure that we won't go from kung fu to sort of laundry folding to elder care. What sort of new applications are you excited about?
I mean, certainly, I think the opportunity is really large, because the idea is that you're just learning how to do motions in the physical world, and you're not necessarily having to predefine them ahead of time. So really, any application, I think there's obvious spaces to start, like in logistics and manufacturing and sort of industrial settings that have a little bit of more structured environments. But I think certainly the opportunity goes all the way to consumer, including, retail, back of the store, front of the store, basically everyday homes. And I think this is actually something that, I mean, you talked about safety, and I think that's probably one of the biggest challenges to get into all of those verticals is actually going to be all those situations around safety and edge cases and privacy and security, those pieces. But I am actually really bold in how fast the models are moving, at really understanding the environment, at really understanding context. These are things that are extremely hard to actually put in one by one as a rule. You can only do this if you can actually really understand how the world works of humans, right? So I think, it is going to be a combination of really advancing the model capabilities and making sure that they're available at the edge, but also developing all of these other safety mechanisms that can work together with the actual foundation models.
Your comment earlier on the skills can't be memorized. They really have to be skills. If you add a layer where a skill needs to be implemented in a safe way, because that's just how you implement a skill. Once you add that capability, now you are kind of talking about the next level of physical AI, which really scales. Yeah,
I mean, you can certainly, these models are eventually just simply, you can think of them as an agent. And an agent can use tools. It can have a safety toolbox that decides what to do in a situation that it feels uncertain, for example. But I think fundamentally, for it to really generalize to do anything, you need to be able to learn everything that it's doing all the way down to the skills. But you can certainly have safety mechanisms that you can back into it, right? In the case that this situation feels uncertain. And even understanding that you're in a situation that feels uncertain is part of solving the problem, right? As opposed to just constantly feeling completely confident that everything is under control. So, yeah.
And I want to sort of close us out. I think you see the audience here filling up the room. I think there's a lot of excitement around robotics at CES in terms of the number of demos that we're seeing companies put up. I'd like to ask all of you to think about, what do you think the current biggest misconception about robotics and physical AI is, that either something people overestimate or underestimate, that you think gets resolved in the next coming years? Maybe I'll start with you, Michael.
I think the gap between videos and lab demonstrations and useful return on investment is something I wish more of the lay population understood. I think we all understand it well, and those lab demos and videos are critical, but there's a gap, and it takes time.
And I'd say the same version of the same story. I think the robot marathon or or kickboxing videos. I mean, we invented doing YouTube video parkour 10 years ago. I know it's a powerful tool, but does not mean the robots are ready. In fact, that's the easy stuff to do these days. The hard stuff is to do the useful work and actually find a job that you can solve at a cost that brings value to a customer. That's hard. That's a misconception still.
I think we'll learn a lot by putting, I do feel hesitant of waiting until everything is perfect to be able to start integrating this technology into the space. I think we will learn a lot by deploying them. But two things that I think will be hard. One is putting them in fully unstructured environments full of people, right? Now you're trying to read the room. Like that concept is extremely hard, and being able to like reason in a very complex social context. And the second thing is, as you guys mentioned, the trust, like building that trust with the user, and that will take making sure the robots are very transparent in their thinking and transparent in their motions so that people know what to expect. So those are the two things that I think are underestimated and will be really hard.
I think what is probably underestimated is how quickly this will move. Because I do feel that physical AI is one AI problem statement that has such mass application. And really the entire industry is going and spending a lot of time on this. And the last 10 plus years of innovation that has happened in many other industries allows you to be able to create this convergence where a lot of energy is being spent. So I think things will actually accelerate massively. I think the other piece that I'm very excited about is that it's a very democratic technology, because you really need this to be available everywhere. Every corner of the world, every engineer, every university, every business and industry has an application for this. So I feel like I think we're going to be continuously surprised. And I think, as all of my colleagues have mentioned, you really have to practice this. This isn't something that you can do in a lab, you can do in simulation. You have to do in a real world environment. That, I think, is going to show the acceleration that's possible.
Amazing. Well, I want to thank you all for joining for the panel. This was an exciting conversation. I'm excited to go from Kung Fu videos to economic value in the coming years. Thank you.
Thank you.